Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning platform. My name is OK Bono. In this lesson, we will be considering crop improvement, and the subtitles under crop improvement, we have meaning and aims of crop improvement, Mendelian laws of inheritance, processes of crop improvement, and methods of crop improvement. Now, let's begin. Crop improvement refers to the ways by which the existing crops or existing crop can be improved or can be developed or can be made better, either through crossbreeding or through various means. Now, what could be the possible reasons for wanting to improve our crops? We can want to increase yield, early maturity. Of course, some crops will mature much earlier than the others, or much earlier than some breeds can mature much earlier than the others, and this can assist in making the crop, for instance, able to be planted more than once in a year, as many times as possible. So that early maturity can be a reason. Also, resistance to diseases. So the fourth reason we have here is adaptation to climatic conditions. The fifth reason for wanting to improve our crops is improvement of quality. And the sixth reason for which we may want to improve our crops is uniformity of crops. Now, these are the possible reasons. There are a number of other reasons which you should do well to find out on your own. But you see, increase in yield, early maturity, resistance to diseases, and of course pests, diseases stroke pests, adaptation to climatic conditions, improvement of quality, and one that we probably shouldn't forget is nutritional value. Nutritional value. Some crops or some breeds of crops will have better nutritional value than others. So we may want to improve our crops, or we may want to improve a particular yield in order to improve the nutritional value of the crops. And now we will go on to look at the Mendelian laws of inheritance. Mendelian laws of inheritance. Now we will consider Mendelian laws of inheritance. There are actually two laws propounded by Gregory Mendel with respect to improving or improvement of crops. The first law is called the Mendelian law of segregation. And the second law, leave it. The first law is called the Mendelian laws of segregation of genes, and the second law is called the Mendelian law of independent assortment. Now, the first law, which is the law of segregation. Gregory Mendel's first law of segregation states that genes are responsible for the development of the individual, the development of the plant, the development of the crop, and these genes are transmitted from one generation to the next generation without any alteration. So you see offsprings, for instance, taking the same genes or taking on the genes of their parents, and then these offsprings will in turn transmit the same genes to the next generation. That is Gregory Mendel's law of segregation. Now, the second law of independent assortment states that these characters, of course, when we talk about characters, you know that characters are the very core ingredients of every gene. Each gene contains a character. Now, these characters are transmitted independently, without any alteration. The laws are actually, they resemble, but you see the first law talks about gene, the second law talks about character. And of course, these characters, they may not, in a generation, in the first generation, for instance, the characters may not become so pronounced. In a second generation, a character, for instance, that was dormant in a subsequent generation may become pronounced in another generation. So let's look at a few examples. This is parent T. We will use capital T to represent the tall parent, and we will use the small t to represent the short parent. So we see two parents come together to give birth to 4 offsprings. This is the tall parent and this is the short parent. Now we have these breeds or these offsprings here. The T, the capital T, stands for dominant gene of tallness, and the small t stands for recessive gene of tallness. Now, what do we mean by dominant gene and recessive gene? The dominant gene is the gene that is manifested physically in the offspring, while the recessive gene is a gene that is not manifested physically, but it is inherent, or it is inside the offspring. It can manifest in a subsequent generation, or it can take effect in a subsequent generation. Now we see this example of 4 offsprings that they are all tall, and if we want to take the phenotypic ratio, what do we mean by phenotypic ratio? By phenotypic ratio, we mean the ratio of the physically manifested traits. Of course, what we have here is a tall crop, another tall crop, and another tall crop. So you see the phenotypic ratio is 1:1:1. Yes, we see tall crops. Now we will take 2 of this and crossbreed. That is, these 2 plants, we will crossbreed them and see what it will give, see what they will give us. Now, here's another example on the board. We have the dominant gene of tallness and also the dominant gene of tallness. Normally, we will see two crops that are both tall, but these two crops also have recessive genes of shortness. Okay, so we crossbreed, and when we do that, we come to this example that clearly shows or clearly indicates that second law, okay, of independent assortment. Now we see that in this second generation of crops, things are starting to sort themselves out. You can see that we have this crop here that is purely short. Yes, this one is tall, this one is tall, this one is tall, but this one is clearly short. Of course, this one has both genes, okay, for tallness. This one has one gene for tallness and another for shortness, the same. But remember that the small t is recessive gene of shortness. So this crop will physically appear tall. So if we talk of phenotypic ratio, for instance, phenotypic ratio. By phenotypic ratio, we mean the ratio of these crops, okay, that is the offsprings, the ratio as per physical or physically manifested characters or traits. So, phenotypic ratio, what do we see? We see a tall plant, another tall plant, and a third tall plant. So physically, we can see 3 tall crops to 1 short crop. Now, talking about the genotypic ratio, good. So, genotypic ratio, we see that we have one crop that is homozygous. Of course, by homozygous, we mean that both genes are the same. Okay? Remember, capital T is for tallness. So both genes are genes of tallness. And we say a plant or an individual is homozygous when both of its genes are the same. And then we see 2 heterozygous genes. Okay, and of course, these genes, this crop is tall, this one too is tall. But remember, heterozygous in the sense that one of the genes here is for tallness, while the recessive gene, which does not show outwardly or physically, is for shortness. The same here. And then we have another heterozygous pair of genes for shortness. So the genotypic ratio is 1:2:1. So that is what we mean when we talk about phenotypic and genotypic ratios. You consider the homozygous and heterozygous natures of the genes in question. Now let us consider the processes of crop improvement. We will be looking at 3 main areas for crop improvement. The first one is introduction. By introduction, we simply mean introducing a new breed or new species of crops, okay, into a particular environment where it was formerly absent. For instance, we can decide to import some really improved variety of crops into Nigeria to boost the nature or to boost the production of a particular kind of crop. Say maize, for instance. We can say, okay, somebody traveled to Ghana and discovered that the maize in Ghana, the type of maize they have in Ghana is so nice, so wonderful. Why not? Let's bring it into Nigeria. Mind you, if you're going to do that, the conditions that made those or that very maize to be well, or that made it favorable, okay, for that very maize in Ghana, you also have to make those conditions available for those maize when they come into Nigeria. So those are some of the things you may want to consider. For instance, for those of us who follow politics, there was a time federal government wanted to import grasses. Well, I don't know whatever happened to those grasses. So maybe after this time out, we'll go and find out if they really imported those grasses. But you see, now the reason for such a move could have been, okay, we need better quality of grasses to feed our cattle. Of course, you can do that. Import grasses, import maize, import seeds of different varieties, okay, into the country, or you can move it within the country from a particular section, from a particular part of the country to another part of the country. Now, when you do that, you are actually introducing this new variety of crops to that area where you are taking it to. So that is introduction. Now, the next process we will look at is selection. Selection, you don't need to import, and you don't need to take any particular crop from here to Kafanchan or from Kaduna to Lagos. No, you don't need to do that. All you need to do is you look within the farm, okay, and those crops that are doing very well, you select the seeds and keep them apart. You can select based on progeny, that is, based on the offsprings. If the offsprings are of a particular crops, the offsprings are doing very well, fine. That's selection based on progeny. You can also select based on cuts. I don't see them.
Are you ready?
You cut them?
You cut now.
I don't cut them.
You cut them. In the record before. They is still recording.
All right. So you can select based on progeny, that is, based on the parents, based on the offsprings. And then you can also select based on the parents, that is, based on pedigree. Okay? You select based on pedigree, you select based on progeny. If the parents are doing well, you take them, you keep them apart for the next planting season. If the offsprings are doing well, you select them and you keep them apart for the next planting season. And of course, you can also you can also do what we call the pure line selection. Pure line selection in this case, kill that thing. Down there. Now you can also select. You can also do your selection based on what we call the pure line selection. In this case, you're not considering whether it is the parent. You're not considering whether it's the parent or the offspring. You simply pick whichever crop or whichever seed, okay, is healthy, and whichever seed you feel is good or can resist diseases. You simply select them and keep them apart. And in so doing, we call that pure line selection. So selection, we have three basic types: pure line, pedigree, and progeny. Now, the third process we will be considering is hybridization. What do we mean when we say hybridization? Hybridization simply means the crossing of breeds. That is, bringing one breed or one variety of a crop and crossing it with another variety of a crop. The crop must be of the same species. That is, where if you're doing hybridization, you are not going to be crossing mango and orange. You're crossing mango and mango. You're crossing orange and orange. So what we're simply crossing are the varieties, not the species. So must be of the same species, but different varieties. And of course, when we are talking about hybridization, we should also be thinking about the types. We have in-crossing, and we have cross-breeding. So we have in-crossing and we have cross-breeding. When we talk about in-crossing, the varieties are related. In crossing, we talk about related varieties. That is the difference between, for instance, if what we are crossing is maize, the maize species, okay, you discover that in crossing, the two crops that we are bringing together, or the two maize that we are bringing together, they are not so far different, okay? Maybe we might just be looking at the tallness, for instance, or the shortness. Sometimes we may prefer a shorter maize. For instance, if we're talking about harvesting using mechanized tools to harvest maize, you don't want to have your maize very tall. If your maize is so tall, I'm sorry, you have to use your hands to harvest. But if they are short enough for the harvesters to pick them, you definitely be, you definitely be doing yourself a whole world of good. Okay, so for instance, you may want the maize that is short, okay, but you probably want it fuller. You want a better yield. And when we're talking of better yield, for instance, what are we talking about? We're talking about the yield per hectare. For instance, if these short maize, we're still on short maize, if the short maize, okay, that we want to plant, for instance, is having about 800 kilograms of maize per hectare, we can say, good, let us crossbreed our maize, okay, with a maize that has a better quality, okay. We'll still have our maize short so that we can harvest using mechanized tools. But this time, let us have it fuller so that we can harvest 2,000 kilograms of maize per hectare. Now, when we talk about crossbreeding, we're looking at far-flung varieties, okay? We can be talking about yellow maize with white maize. We can be talking about yellow maize with white maize. We can be talking about crossbreeding the tall and the short maize. A whole lot of characteristics come to play, okay? Now, remember, the very reason for all of this is to get a better yield of crops that are more resistant to diseases, crops that can adapt better to certain climatic conditions, crops that will yield more or better nutritional values, and so on and so forth. Now, we'll go on to look at the methods of crop improvement. Now, quickly, let's wrap things up. Methods of crop improvement or methods of improving crop productivity. We have just considered processes, okay, of crop improvement. What were the processes we considered? We looked at introduction, we looked at selection, and we looked at hybridization. That can also form one of the methods, okay, of crop improvement. Now, the others we will be considering, we have proper timing of plants or proper timing of planting. We have better cultivation methods. We have use of manures and fertilizers, control of pests and diseases, and finally, we have the use of resistant varieties. What do we mean when we say proper planting timing? You have to know, if you want to plant, when to plant your crop. If it's a crop that you should plant, for instance, at the beginning of the rainy season, you have to plant it at that time. If it is in the middle of the rainy season or towards the end of the rainy season, you have to know at what point to plant your crop. The reason is, if you miss the timing, you can expose your plant or your crop to diseases, to certain conditions that are unfavorable or that could bring about the onset of diseases and pests. And of course, such a crop may not survive. Now, better cultivation methods. There are several methods, okay, that one could use. For instance, crop rotation is one very good method. You don't keep planting a particular crop in a particular place year in, year out. It is well known, for instance, that if you plant cassava, okay, for instance, over a space, in the next season, it will be proper for you to plant crops, for instance, leguminous crops that will help to rejuvenate the soil, okay, and make it more fertile, and all the nutrients, okay, that may have been removed from that very area where you planted that cassava will be replenished, okay, by the planting of leguminous crops. That is crop rotation. Now, the use of manures and fertilizers. That's one very important aspect of farming that you should know about. The use of manures, the use of fertilizers. Manures, you can produce manure locally using dungs of animals, okay, feces of poultry and all of that. And of course, fertilizers, you have to buy fertilizers. The most common one we know is NPK. Okay, NPK stands for nitrogen, phosphorus, and potassium. Okay, mixed in varying degrees depending on the requirement of the soil where it will be applied. Now, talk about control of pests and diseases. Very important. We have, of course, pesticides and we have herbicides, different types, okay, that could be used to control, that could be used to give you good and quality yields of your crops. Then we also have the last one, which is resistance to diseases and of course to pests. If we use resistant varieties of crops, you're sure that your crops will do well, very well, okay? And that brings us to the end of this topic. So far we have considered the meaning of crop improvement, which talks about the ways that we can use, okay, the ways by which we can improve the quality of yield of our crops. We talked about the aims for crop improvement. We talked about the Mendelian laws of inheritance. There are two of them, the law of segregation, the law of independent assortment. One is particular about, the first is particular about the genes and the second is particular about the characters, okay, which get to show up in subsequent generations of the crops. Now we talked about the processes of crop improvement. We talked about selection, we talked about introduction, selection, and hybridization, and then lastly we treated the methods of improving crop productivity. Very soon some questions will pop up on your screen. Please do well to attempt them, and if you have any issues, go back, replay the video.